Hi everyone, today's lesson is about graphing the sine function. And in order to do that, we're going to go back to the unit circle. So if you don't remember things that I'm going to talk about the unit circle, then you should go back to your notes, back to the slides, back to the test you took on the unit circle, okay? To review these concepts. So in our unit circle, we have that x is equal to the cosine of the angle theta, and y is equal to the sine of angle theta. And every single angle that we have is related to a point on the circumference of the unit circle, and that point has an xy coordinate where x will be cosine and y will be sine. Okay, so we're going to use that to start graphing. The graph, over here I have an x and a y axis. These are going to be x and y. I'm going to define the vertical axis right now as the sine of theta. So this is going to be y equals sine of theta. And my horizontal axis won't be cosine. My horizontal axis will be theta. So we're going to graph how the sine function changes its value depending on the angle that we're talking about. So in order to do that, I'm going to start by drawing an XY table where I'm going to have over here, my independent variable is my theta, and my dependent variable is the sine of theta. So let's pick some really easy angles first, just to start with. What if my angle theta is 0 degrees? Right, 0 degrees. Well, if my angle theta is 0 degrees is going to be right over here. And this point over here is going to have the coordinate 1, 0. And my sine is a y coordinate. This means that my sine of 0 is equal to 0. Therefore, going back to my table, I'm going to have that if my angle is 0, the sine of 0 will also be 0. Moving on, what if we have, I'm going to pick the easy angles over here. What if we have theta equals 90 degrees? Well, 90 degrees is going to be a point up here on my y-axis. This point over here will have the coordinates 0, 1. This 1 is going to be my sine of theta. So whenever theta is 90 degrees, sine of theta is going to be equal to 1. And we can keep going. What if we have 180 degrees? If theta were 180 degrees, we would have this point over here. This point has the coordinates -1, 0, which means that my sine will be once again equal to 0. We can keep on going. What if theta were 270 degrees? If it were 270 degrees, we would be in this point over here. This point has the coordinates 0, -1, which means that my sine is -1. And we can go all the way through. If we had 360 degrees, we would go back to our first point, because 360 degrees, the terminal side is on the same spot as 0 degrees, therefore my sine will be 0. And we could keep on doing this for any value of theta. Okay, so let's start graphing. Whenever we have theta over here equals 0 degrees, so you need to look at my table and at my graph, okay? So you understand what I'm doing over here. So if my theta is 0 degrees, my sine of theta up here is going to be 0. So I'm going to have this point over here, 0, 0. What if I had 90 degrees? Well, 90 degrees, let's mark 90 degrees in my graph. I'm going to mark all of the x-axis. So 90 degrees, 180 degrees, I'm going to have 270 and 360, because they should have the same space between them because they're all intervals of 90 degrees, right? So if we had, I'm also going to make, on my y-axis, I know the maximum value my sine function can have is 1, and the minimum value is -1. So I know that my function shouldn't cross y equals 1, and shouldn't cross y equals -1. And hopefully my lines are straight enough so we can start graphing. Okay, so going back. If I have a theta of 90 degrees, my sine of theta will be 1. So let's graph that. Theta is 90, sine is 1. Okay, if theta is 180 degrees, looking at my table, I get 0. If theta is 270 degrees, my sine is -1. And if theta is 360, my sine is 0. If we connect all those points, we're going to see that our sine function looks something like this. And it's going to keep going up and down for all infinity. Now, what happens if we go backwards in our graph? So if we go backwards, it's the same thing as going clockwise on our unit circle, right? So the first thing that we would do is -90 degrees. -90 degrees, you go clockwise. We end up with a point down here. And this point has a coordinates 0, -1, which means that at -90, we have -1 as our graph, as our sine value. What if we had 180 degrees? Well, 180 degrees, we're going to go backwards over here, -180 degrees. This is going to be the point -10, so our sine is going to be 0. What about 270? Well, if we keep on going, -270 degrees will be this point over here, which we already know. This is the point 0, 1, which means that our sine of theta will be 1. And if we go all the way to -360, we would end up back at 0. So -360 degrees, sine is 0. And we can easily graph that. So if I have -90 over here, -90 degrees, we're going to have the point -1 down here. If we have -180, we're going to have the point 0. And if we have the point -270, we're going to have 1, and so on and so forth. So we can complete this graph now. Down and up. So as you can see, the sine function, it forms a wave-like structure. It's usually called a wave function or a periodic function because it repeats in regular intervals, right? It has a fixed period where it repeats itself. Before we move on, I just wanted to call your attention to something important, which is that I made this graph using angles in degrees, but 99% of the time, you're going to get a graph where your angles will be in radians. So it's important for you to remember how to convert from degrees to radians, or better yet, you shouldn't be converting anymore. You should have memorized the value of some angles in radians. So a few angles you should know. You should know that pi radians is equal to 180 degrees. If you haven't memorized that by now, write it down on a piece of paper, glue it to your forehead, sleep with it, remember it until you die, okay? Pi is 180 degrees. Therefore, if we went half of pi over 2 will be half of 180, which is 90 degrees, right? If we get 90 degrees and we multiply it by 3, we get 3 pi over 2 is 270 degrees. And if pi is 180, 2 pi will be equal to 360 degrees. So usually, when you look at a graph, instead of getting 90 degrees over here, you're going to see pi over 2 written wherever there's a 90 degree. Wherever there is 180 degrees, pi, just pi, right? 270 degrees, 3 pi over 2, and 360 degrees, you're going to have 2 pi, and so on and so forth. Same thing for the negative sides. -90 would be negative pi over 2, and -180 would be negative pi.